Hello everybody and welcome to our lesson on writing equations from roots. This short little lesson will be the last lesson in our Unit 3 on quadratic functions, and today our objective is we will write a quadratic equation given the roots. When we have roots that are the solutions of our quadratic equation, we can use those and go backwards and find out what the original equation was. So for our first example with the solutions x is equal to 3 and -4, the equation would be f of x is equal to x minus 3 times x plus 4. Remember, we have to switch the signs. And then we just go ahead and we multiply this out. We FOIL it. And then we get f of x is equal to x squared plus 4x minus 3x minus 12. Combining our middle terms, we get f of x is equal to x squared plus x minus 12. Looking at our next example, f of x is equal to x plus 3 halves times x minus 4. Now that fraction in our first factor kind of bothers us, so the trick is, if we want to get rid of the fraction, we just multiply both elements by 2 times 2 times 2, and then we end up with f of x is equal to 2x plus 3 times x minus 4. And again, go ahead and multiply this out. Using our FOIL method, we get 2x squared minus 8x plus 3x minus 12. And f of x, after combining the middle terms, is 2x squared minus 5x minus 12. And in our last example, we have two fractions, so f of x is equal to x plus 1/2 times x plus 3/5. But with our little trick, we multiply in our first parentheses, multiply both terms times 2, and in our second parentheses, multiply both terms times 5. So now we got f of x is equal to 2x plus 1 times 5x plus 3. And again, we can go ahead and multiply this out, FOIL it to get our equation in standard form. Remember, ax squared plus bx plus c is standard form. Now, where did we start off? Looking at these versions of our equation, we used our solutions to get started here. Our solutions are the same as our x-intercepts. And guess what? Those three versions here that I highlighted, that's intercept form. Remember intercept form? Well, that's why it's called intercept form, because it shows us the intercepts. And if the solutions are there, we start off like that. And we could have left off like right there. And that's what I'm doing for our equation in green, because that is just another form of writing a quadratic equation. It's intercept form, right? See how all those things fit together nicely? All right, then let's look at cases where we have irrational or complex roots. Well, we could write our function by creating factors and multiplying them out. X, since the 2 is positive, it would be minus 2 plus 3 times the square root of 2 times x minus 2 minus 3 times the square root of 2. Now we would have to multiply this all out and FOIL all over the place, right? Well, what are we going to do with the middle term and this and that? And it would get very confusing and we would get very frustrated. And so let's not do that, all right? Instead, I'm going to show you a method which is way easier, and it's called uncompleting the square, because guess what? That's exactly what we're doing. We are using the completing the squares method, going backwards, and this is how it goes. We have our solutions. X is equal to 2 plus or minus 3 times the square root of 2. Now we need to move everything away so we have the term with the square root isolated on one side. In this case, we just subtract 2 on both sides and we get x minus 2 is equal to plus or minus 3 times the square root of 2. And now, remember, we got the square root because we took a square root. We reverse that process now. We are squaring both sides of the equation. So we get x minus 2 times x minus 2 on the left. And on the right, since we had two solutions, a positive and negative, but remember, when you take a positive or a negative number and you square it, you always end up with a positive. So here we get 9, and the square root of 2 times itself, we get 2. 9 times 2 is 18. Now we FOIL the left side to get x squared minus 4x plus 4 is equal to 18. And in our next step, we will subtract 18 from the left in order to set our equation equal to 0. X squared minus 4x minus 14 is equal to 0. And that is our function. F of x is equal to x squared minus 4x minus 14. All right? And if we have even complex roots, we do the exact same thing. So starting off with our two solutions, the first thing we need to do is we need to isolate the term with the square root. In other words, first we needed to actually multiply both sides by 4 in order to get 4x is equal to 3 plus or minus I times the square root of 2. Now we subtract 3 from both sides to get 4x minus 3 is equal to plus or minus I times the square root of 2. Squaring both sides of the equation, we get 4x minus 3 times 4x minus 3 is equal to I squared times 2. Now let's go ahead and simplify both sides. On the left, we're going to FOIL, and we get 16x squared minus 24x plus 9. On the right, remember, I squared is equal to negative 1. So negative 1 times 2 is negative 2. And in our last step, just add 2 on both sides to get 16x squared minus 24x plus 11 is equal to 0. And here goes our function. F of x is equal to 16x squared minus 24x plus 11. Make a nice circle about your final solutions, your final answers. And that's it for today. All right, I will see you in class.